The process of climate change is real and is considered one of the most serious threats to our planet. The use of information communications technologies can play a contributing role in mitigating the impact of climate change. On April 20th, 2011, the Telecommunications Authority of Trinidad and Tobago held its 7th installment of the ICT Open Forum series, entitled The Use of ICTs in Combating Climate Change. Mr. Selby Wilson, Chairman of the Telecommunications Authority of Trinidad and Tobago, delivered the opening remarks.
Ladies and gentlemen, greenhouse gas emissions have been identified as a major driver of change to the global climate. Activities by man have been identified as the probable cause of rising greenhouse gas emissions, particularly carbon dioxide. It is widely held that if climate change is attributed to rising greenhouse gas emissions as a consequence of human activity, then cutting greenhouse gas emissions will require that all humans make changes in these activities. For some persons, the subject of climate change and the role of human beings in causing same remains controversial. However, the Stern Review on the Economics of Climate Change, a 700-page report released for the British government in October 2006, stated, and I quote, "The current level of or stock of greenhouse gases in the atmosphere is equivalent to around 430 parts per million of carbon dioxide, compared with only 280 parts per million before the Industrial Revolution."
The Intergovernmental Panel on Climate Change, IPCC, is the leading international body for the assessment of climate change. Its 2007 report found that temperature increases have already affected many physical and biological systems. The major contribution of ICTs to climate change comes from the proliferation of user devices, all of which need power and radiate heat. Mr. Richard Labelle, president of Aylmer Group of Canada, shares his insight into how ICTs can reduce its own sector energy requirements through new technologies and next-generation networks.
So there are really four noteworthy trends that are converging. One is the rise of humans, i.e. the increases in people, wealth, and intellectual resources, especially the wealth side, in emerging countries, as a major game changer globally. The rise of demand for energy, resulting directly from the increasing demands of an emerging middle class around the world, and especially in the larger emerging countries of China and India. Fossil fuel emissions are tracking surface warming. In other words, the more we burn, the more we emit in terms of, the more we use fossil fuels, the more we emit greenhouse gases, the greater the rise of temperature is. It's virtually a linear relationship. Land use is also a major contributor to greenhouse gas emissions, largely as a result of cutting trees down, so eliminating carbon stocks, various agricultural practices that encourage the oxidation or the release of greenhouse gases from the soil, from nitrogen sources and so on. So I've spoken about the problems, and let's look at some elements of the solution. And I'm not saying that information technology is going to solve our problems, but without the technology, it's going to be very difficult to deal with them. And let's look at some of the merging, what I call the sort of various technological innovations that are now taking place that are coming together and, in my opinion, offer us a dramatic opportunity to address these issues while at the same time creating health, wealth, and well-being for economies and countries around the world. Digitization and dematerialization. Digitization, forget the analog world, we're now going to a more digital world. That has very big advantages. Digital broadcasting, for example, is much more energy efficient. Dematerialization, travel replacement, that as a result of travel replacement, and not traveling and using high-definition video conferencing, a technology called telepresence, We're seeing a major fight now between two big processor companies, Intel, which everybody's familiar with, and ARM, which is actually what's much closer to most of you because it's in your cell phones. We're now seeing a transition from desktop and laptop devices to handheld devices. I have a little netbook. The most recent editions of the iPhone, the various Android devices on the market are more powerful than my netbook. So IP6 is the next iteration of the Internet Protocol, the software language, if you want, the rules that regulate computers on the Internet, objects on the Internet. Cloud computing, where we're now moving all of our services, all of our applications to the cloud, that is the distributed servers connected together by high-speed connections and provided by a variety of companies like Akamai, LimeWire Networks, I think it's called, which are content distribution networks. If you go to YouTube, your YouTube feed is coming from a server based on the cloud that is managed by one of these companies. Let's look at the Internet of Things. Today, there's about 87 million embedded mobile M2M, that's machine-to-machine connections that are taking place, at least last year. This will grow to about 428. We're seeing SIM cards that are becoming embedded in mobile phones. This is something that regulators will have a lot of fun with because in some cases, users can directly control their connections. So the operators ain't going to like that. So what does that mean? We're not there necessarily yet here, but it's starting to be considered. So what are we going to do about it? Let me see. This is basically mentions the beginning of the introduction of Internet of Things related technology. RFID, radio frequency identification tags, really dumb sensors. They just detect presence. They pass near a detector, they go beep, and you know that someone's trying to rip off the shirt from the store. Okay? That's the sort of basic thing that does. Great application for retailers and some other specialized security applications. But as we add more intelligence and capability, because as I mentioned earlier, we've got new microprocessors, we've got smaller batteries, we've got all these other neat things happening, we start getting into some really interesting applications. Surveillance, security, healthcare, locating people and everyday objects, teleoperation, ability to monitor and control distant objects. So all of these things are happening. So what are these wireless sensor networks that are going to make this Internet of Things happen? They're tiny sensors, or some people call them nodes, that collect and relay data to a network of similar nodes. If you distribute these sensors, and they're not that small, in the environment, you can actually measure a variety of different parameters. From a disaster risk reduction monitoring perspective, you can look at soil slip, you can look at water levels in soil, which might lead to soil slip. You have seismic meters, you've got vibration meters in bridges, it goes on and on and on. Anything that's physical, roughly, and to some extent chemical, although it's more difficult for wet chemistry, can be measured by some of these sensors. So, in conclusion, ICTs have a key role to play in instrumenting changes required to abate climate change. At this stage, it's still new, so we're in the early stages of discovery. We need to be able to communicate more clearly the role of these technologies and encourage greater investment, greater awareness about them. In fact, one of the things that those countries that have seen the opportunity are doing is to promote greater awareness, countries such as Korea, and to some extent Japan, especially Korea, greater awareness and use of this green growth concept whereby we now not only are transforming the environment around us, we're now using these smart technologies in our processes, our industrial processes, so that we limit as much as possible pollution, emissions, and increase and enhance the efficiency of energy use.
Jewel Becher Singh, Climate Change and Ozone Specialist at the Environment Policy and Planning Division, Ministry of Housing and Development, and Professor Paul Shaw, Professor of Geography in the Faculty of Science and Agriculture at the University of the West Indies, both share their own on-the-field applications and experiences.
Trinidad and Tobago is now developing its climate change policy. As Mr. Labelle indicated, you can use these technologies to get baseline data, which is very critical, especially in the climate change field, because there are naysayers, people who do not believe that climate change is happening. And the proof is in the pudding. If you tell people, you can't tell people, my father used to say it used to rain now. You have to tell them, you have to show them data, then they believe you. The other area that we see is that of public awareness and education. Social medias, the use of mobile phones, internet, all the different applications. It is phenomenal that there's so much we can do with it. The last use of it is, of course, in the adaptation side of things, where we look at disaster risk reduction. The remote sensing technologies and all those satellites, those are very important technologies. And we saw them being used very recently in Japan with that tsunami occurring. And that type of technology is very important. Trinidad does not have that type of technology now, but it's something that we can look to in the future.
We live in a hydrocarbon-rich economy. Petrol is subsidized. Our electricity bills are relatively small. We don't have the mindset that switches off air conditioning and the rest of it. And basically, it's going to have to be a mixture of education and fiscal challenge, in a sense, to make the populace at large adopt some of these very useful technologies, which are being adopted pretty quickly now in Europe. The idea that you can switch off your air conditioning as you drive the car down the drive, that's great. But we have to make it worthwhile for people to do that, to think that it's a good idea to invest in that technology.
How relevant is a smart grid to Trinidad and Tobago?
I think the smart grid is a cutting-edge technology that might be more appropriate in other countries than it might be initially here, but it does not mean that Trinidad and Tobago should not try taking advantage of these cutting-edge technologies. It should not mean that, and I believe it should not deter innovators in the country from looking at applications that can be written for this application area, but the smart grid applications that have probably the most significant direct impact on energy consumption. It's not a priority because Trinidad has other priorities.
If wireless technology have a negative impact of radiation and implementation of all these technologies, will Trinidad and Tobago be a better place?
And I'm not a specialist in this area, my sense is that it's not a major problem, but it's true, as I said, we're looking at connecting everything, and that means bouncing all kinds of frequencies, all kinds of signals off all kinds of things, and then we'll be in the middle of it. So I think it's a valid case to raise, and because we would like to, as we move ahead, and according to the principles of sustainable development, we need to adopt the precautionary principle. We need to be clear on what we don't know.
We know the government is doing a lot of tax incentives to encourage green technology, as well as you mentioned that you're doing this drive with education and empowerment. But to what extent is the government or the ministry encouraging companies to actually get involved? For instance, is there a review of legislation to encourage electricity generation and distribution? Because currently the framework doesn't allow for that.
I think the first step, you've asked if the private sector is getting involved in these practices. We've talked today about technology transfer, and it ultimately is happening with private companies because, of course, private equals you have your own money. The government, of course, is committed, and I think the statements were made by my line minister in the Minister of Housing and Environment that we are going to go green. And that would incorporate all these simple things like trying to change out the lights in the buildings and even changing out the government's fleet to CNG. So those types of measures, which are also reflected in the policy, will be happening. Of course, the time frame, which is part of the question I was asked before, is that we cannot determine how long it will take because then essentially that depends on how well I do my job. But I think the first step in getting there is getting the policy to cabinet and getting it formalized and then rolling it out.
So again, on behalf of the authority, I'd like to thank everyone for participating. As you know, the ICT Forum series is one of building awareness on very topical issues facing the country in our own sphere. As a telecommunications regulator, ICTs is our business, and therefore we chose this topic. And certainly from what I've heard today, we would have realized part of our mission in certain creating the awareness on the use of ICTs in this particular instant in sort of combating the effects of climate change.